Good afternoon. We're going to go over our vitamin chapter. And within your textbook, the Contemporary Nutrition textbook, it goes over more than just vitamins. In the past, we have used a textbook that goes over vitamins separate, or fat-soluble vitamins separately, water-soluble vitamins, then water by itself, and a little bit of phytochemicals. But really, your textbook, the contemporary one, lumps them all together. So even though for this unit you only have two chapters, it really is a very in-depth unit. So that's why there's only two chapters for this one. So quite a bit of information. You want to make sure that you really stay up on reading and studying within this chapter, and that's one of the reasons why these videos are being sectioned out for you. But in this video, you can see we're going to first look at just an overview of vitamins and just what's the difference really between the fat soluble vitamins and the water soluble vitamins. We'll look at bioavailability. We're going to look at some food sources of a few of them. You're not going to have to memorize every single recommendation when it comes to vitamins. It's only going to be some of the very important vitamins that here in the US we are tend to lack in our diet. So thinking about the discovery of the first vitamin, well, people knew that there was something lacking within the diet that if you did not eat enough, of course, you got sick and you ended up dying. And if you think about back in the days of when people would have to travel by boat to another land, that was many, many months of traveling with the food that they could only pack in at the beginning of the trip. They're not going to get fresh fruits and vegetables along the way. They're not going to stop by the local HEB or grocery store. And so, really, they had to eat up what is fresh at the beginning and then save what it can be preserved, like grains and some of the meats, for later on. So, this particular gentleman that you see up here on top, or at least the cartoon version of it, we're looking at. You see some bleeding gums in here. You also see what's known as some petechiae, and that is some open pores that are bleeding. And then these men who would, let's say, either pirates or we could say soldiers rather, who would be traveling to try to get to another place, besides bleeding gums and this bleeding from the pores and the hair follicles, they would end up having more likely to have or at least get a contagious disease, virus, bacterial infection as well. Big issues, and so especially within a lot of the era where the British were conquering different lands, they wanted to really push forward the science in order to resolve this issue so that they could have healthy troops when they arrived to the land. All right, so one of the very first researchers that we have really studying vitamins is James Lind. He was an apprentice in the Royal Navy and he was sent out to try to solve this big issue of death among a lot of the British soldiers as they traveled across for weeks and months at a time in order to get to another land. And so he worked with some other fellow physicians and he came up with one of the first really reported or documented clinical trials, and he separated men into different groups. And he had one group having a little dosage of cider every day, a second one having a little dosage of seawater, next one a blend of different spices. The fourth group had 2 spoonfuls of vinegar 3 times a day, and then the fifth one had 2 oranges and 1 lemon a day. And these men who were sick, you have to understand that they had scurvy, what we can now call scurvy, but their symptoms were, besides infection, they had bleeding gums, ulcers in their mouth, they had blood coming out from their different pores. So very, very painful, very, very tired soldiers. And you can only imagine what it's like to have those dosages of either cider, vinegar, or citrus stuff within your mouth when you have a mouthful of ulcers. However, that group number 5 who had the citrus dosage every single day were well enough. Their symptoms improved by the end of the week in order to be able to actually assist in helping with those soldiers who were not well. And so is really linked then as understanding that there is something besides just a particular food, but something within that food that is specific, and that is what that either maintains health or improves health. All right, so looking at the discovery of vitamins, it's not really a scientific method. When they first discovered vitamins, they named it vitamine. Vitamin and amine is part of a chemical structure of a protein because the first one that they actually discovered and they could actually research more and look at structure actually, in fact, did have a part of a protein. But later on, that they understood that not every particular vitamin actually has a amine group on it, and so they dropped the E later on, and now we have vitamins. And they had a very scientific nomenclature here as they started naming them from alphabetical order. You have vitamin A that was first discovered, and then B, which was actually thought to be one particular vitamin, but they later discovered that it actually is more. And so that's why later on we'll look at the different subscripts of vitamin B. But you can see that it was about 1900s that we really finally were able to have the scientific testing procedures in order to name it further or to find the further details of those particular vitamins for nomenclature. On the very bottom of the screen, I'll just point out here briefly, is vitamin C. Vitamin C definitely is the vitamin that is linked to scurvy. So this particular gentleman was our example earlier on who had the bleeding gums. His issues were resolved with citrusy things like limes, lemons, and thinking about those soldiers, their fresh produce, fresh fruits, they dwindled out after just a couple of weeks. And so they had to maintain their diet mostly on starches and some meats and fish, of course, that they could catch, none of them containing vitamin C. This is the particular nutrient that was deficient in the disease linked to scurvy. I would highlight this. You definitely need to know these. Okay, briefly just looking at some of these structures, and no, you do not need to memorize these structures, but it gives you the holistic idea that each one of these vitamins is one single unit. It's not a whole bunch of chains like we saw within our macronutrients like carbohydrates and lipids, who had some medium chains, long chains, etc., very branched chains. Very simple, very unique structures here. And guys, I've already mentioned in our previous slide about the discovery and the nomenclature of vitamins. We really thought that there are many more vitamins that we actually have or know that are known now. And later on, through more research, we understood that some of those weren't actually vitamins. There were other nutrient types of sources, but they're not vital. And looking at that word here is vita itself means it's vital to life. And so if you take something out that's a vitamin, then you will have disease and eventually you will have death. And some of these nutrients, for instance, let's talk about fiber. Fiber is very beneficial, but does not necessarily mean it is vital to health. And so you wouldn't necessarily die from lack of fiber itself, but acutely, you could die from a lack of a vitamin. And so later on, when they decided, hey, this particular nutrient is not really vital to life or maintaining life, it is more beneficial, they started to drop some of these other types of nutrients. They are more probably certain things like phytochemicals. We'll look at those later on. Same thing with B, I'm sorry, that I mentioned briefly. We're going to see that when we look at the B vitamins, we're going to have B1, and we're going to have B2, and then all of a sudden it's going to start dropping off, and we're going to have some big gaps within those numbers. Same thing. We thought B vitamin itself was one type of thing. Then more research came on. We were like, oh no, these all have different functions within a human being's life, and so we have to separate these out. And so they started to really have their own particular subscript. And then more research, and we realized, oh, hey, that's not actually a particular vitamin. We need to remove it. It's more of a, maybe more of I guess you could say non-nutrient, or you could say a phytochemical, zoochemical. Is beneficial but not vital. A few things that you need to know about vitamins. You need to know these right here, that vitamins are indeed organic. They are micro, does not mean that they are not as important as macronutrients, but they are needed in smaller amounts. They are essential to life. Without them, you will eventually die. There's that amine group here. We got rid of the E eventually. They do not provide any energy. And so, again, if you hear someone saying that they need more energy, I'll go take my multivitamin, they are lying. That is not how it actually works within our bodies. And then we're going to learn here with each particular vitamin how they are classified. They're either going to be classified as water soluble or fat soluble. Okay, guys, so we have 13 different vitamins that we're going to be going over, and you do need to know these. I'm going to tell you a little bit about how much of the details that we need to know, and some of them you don't need to know as much of. We're going to spend a lot of time on certain types of nutrients, especially like vitamin A and D. Definitely some thiamine in there. Folate we'll spend some more time on, and some of them we'll go a little quicker through. All right, so we're going to separate our vitamins first into two main groups. We're going to have either water soluble or fat soluble. So if I was to throw out one of these, either vitamin D or riboflavin, you should be able to tell me, hey, is that fat soluble or water soluble? If it's not ADIC, A, D, E, or K, then it must be water soluble. So it's going to be a B vitamin or it's going to be C. Need to know what's the difference between these two fat soluble vitamins. They are able to be stored within your body. They require fat in order to be digested and metabolized. They also require fat to be stored, and so they're going to be stored in your fat tissues, but also our liver, kind of that brain major organ within our bodies, is going to also house all of these vitamins. Because we can store them, that means that we could potentially get too much of them. That is very different compared to our water soluble ones. Our water soluble, almost all of them, almost, we get rid of them very well if we get too much of them. And we'll see that evidence here later on when we get into riboflavin. All right. But because of this, if you want to think about that, if you can store fat soluble vitamins, that means you're less likely to run out of them. Our water soluble ones, because we get rid of them within our urine, that means that we need to replace those on a regular basis. And so if you don't get them enough, more likely to have a deficiency in these types of vitamins, vitamin C, and all of these listed here within the B vitamin classification. This is a great little chart here to just have, and it gives you that very basic glance or overview of the differences between fat soluble and water soluble vitamins. We learned this one particularly. There's a test question on there some of you may have received, that our water soluble vitamins are transported through our blood or circulatory system, and our fat soluble vitamins, they're going to follow the same pathway as fats do or lipids do, and they're going to travel through the lymphatic system. And so they're going to go through the lacteal. They're going to have or be transported through the same types of major phospholipid surrounding types of molecules, and they're going to go into the lymphatic system, go into eventually meet up to the hepatic portal vein and to your liver. Your liver is that brain organ. Is going to decide whether how much it needs to store of those types of fat soluble vitamins and what it can disperse amongst your body in order to have those necessary functions completed. All right, so this is a great little review chart here. All right, so you're not going to have this particular table within your textbook, but I think it's a great little snapshot to have because it really underlines the importance of distinguishing between the different types of functions within our vitamins. And so when I'm usually in lecture in our in-person classes, I have students kind of write a diagram. I'm a visual person, so I have them kind of draw out pictures of different functions, like what does energy look like? It'd be a lightning bolt, and for growth, maybe a baby, or muscle or protein being kind of a muscle type of drawing. And then I get them to kind of link the different vitamins and minerals later on that we're going through to particular similar functions. For instance, if we think about bone health, and that is right here, bone health, I would have them draw a little picture of a bone. This is going to look horrible because I'm trying to do it on a stylus. And then I would get them to link everything or every nutrient that we cover to that particular diagram that I guess you could say that it is. So I would say vitamin D, calcium is previewed this way, calcium, and we're going to go over vitamin K. These are all nutrients that function in maintaining good bone health. And most people will obviously know that vitamin D and calcium are important for good bone health, but they may not know some of the lesser nutrients that are still very important within that function. And so to me, having that kind of study guide is effective, or at least it was for me back in the day when I was in undergraduate studies and graduate studies. All right, so I don't need you specifically to memorize this table, but there definitely will be some questions that will ask you to link a function of a vitamin to a particular action, a deficiency, or a disease later on in the exam. So what is this slide really illustrating? And that is that every food group offers different types of vitamins and nutrients, minerals as well, and phytonutrients, but they don't all equate to one another. For instance, you have vitamin D here. It's only going to be seen in primarily animal sources. We're going to see that vitamin C is going to be in more produce, especially our fruits, our citrus fruits. And so for those individuals who do not eat a variety, which is one of those dietary recommendations, that basic healthy diet is to have a variety, then you're less likely to get all the essential nutrients that are vital for life. And so that is one of the reasons why we recommend to have a variety of different types of foods in your diet. However, I must stress, just because you eat something, or at least one food from every food group, does not mean that you have a good variety in your diet. There are specific nutrients that are really only found in one or a few types of fruits. And so if you only, let's say, eat an apple every single day, that does not mean that's great that you have a fruit every day. It's going to give you lots of great beneficial nutrients, but that's not variation. You have to have a varied diet within that particular food group. So if a diet really restricts the types of fruits that are allowed on it. I'm going to pick paleo, for instance. It really refines what you can eat, basically a few berries, different types of berries. There's a avocado, of course, but it does not allow you to have a good variety of foods. And all of those fruits have specific functions that are necessary for good health or overall health. Not all of them primarily being just vitamins, but also phytochemicals that really help to enhance the quality of your life. Now, bioavailability. You are going to hear this word over and over and over within the remaining of this semester. Bioavailability means how much of that particular vitamin that you will be able to absorb from the foods that you eat. Just because you look at a food label and it says that it contains 100% of, let's say, vitamin C, does not mean that your body is going to absorb 100% of that. Bioavailability means that sometimes, depending on a particular way food is cooked, or your body's need, or how old that particular food is, say it's older produce versus fresher fruits or vegetables, it's going to change how much or percentage wise that you will actually absorb and use. The rest of it has kind of deteriorated. Or it's going to be passed throughout your body. And you see what is outlined here is that about 40 to 90% of the vitamins in your food will actually be absorbed. The rest of it is lost. How can we affect that? You should know that it could be the way you prepare food. It could be your own health. I don't need you to memorize these right here. Know this overall factor here is that the efficiency of your digestion, your absorption of food, which in reality is, do you have a disease? Do you have some type of chronic health condition that restricts your body's ability to digest or absorb that food? That is what we're talking about that could really affect how much that you're getting of the nutrients within the foods that you're eating. Just because you put them in your mouth does not mean that you're actually going to get the nutrients from it. All right, continuing on from this, number 3, we have the individual nutrition status. A good example of this is the nutrient or mineral calcium and pregnancy. During pregnancy, your ability to absorb calcium almost doubles. And so that is an example of, because of a condition, you need more because you're forming a human being with bones. You're going to need more calcium in order to do so. So your body turns on some certain types of gene receptors in order to tell you hey, we need more of this nutrient in order to support growth and development of this child. That's an example for that. Now, our foods and nutrients that we can consume at the same time. This is a prime example, and I would know these because we go over them over and over. And I realize that this cameo is blocking this particular picture, but you will see it many times. All right. Nutrients tend to either have a love or hate relationship. Very good example, you will see this on several different test questions, is iron and vitamin C. You should know this relationship. They love each other. So if you are anemic, that means you need more iron within your diet. And just because you eat that food that has iron doesn't mean that you're going to get 100% of it. Well, if you want to boost it, have some vitamin C with it. You could take, I'm going to give you the most random, oh, well, obvious one is steak. Steak, it's got kind of that good blood that tells you that it's going to have iron in it. That's where we get a lot of our heme iron from. If you take that and you have some vitamin C with it, I'm going to take the most obvious source. Orange juice doesn't really go together with steak, but you get the idea. Have that together, you are going to absorb so much more of that and you're going to improve your anemic status. Now, there are others that hate one another, and that is calcium and iron. So, same person, they're anemic, they are trying to boost up their iron. Let's say that they have an iron pill. For it could be an iron food. Same thing with steak. We'll just keep it with steak. They have a steak, and instead of orange juice, they have milk with it. Again, not something I would ever have with steak, but a good example. You have that milk with calcium in it. That iron in the steak and the calcium within the milk are going to fight one another in order to be absorbed. And so sometimes more of the calcium will tend to be absorbed than the iron. So the iron that you ate from the steak continues to be passed on through your small intestine. It's not going to be absorbed, it's going to continue on to your large intestine. Know these love hate relationships. So, besides just the diagrams that I tell you to draw, I always usually say, hey, make a little table over here. Have those that are friends and then also those that are foes. And you'll also help yourself when it comes to exam time. All right, so there's a little bit more nomenclature that I want you to know. As we get into each individual nutrient, there will be some that are ready to go and active and some that are inactive. And this slide shows you a precursor, which is sometimes known as a provitamin, or indeed an inactive vitamin. That means that they can function on their own inactive structure and do wonderful things for your body. And a great example of this is beta carotene. Beta carotene, before it's activated, can function as a phytonutrient. It can do other things to support good health. But let's say your body requires vitamin A in order to, let's say, build a cell. It can activate it by changing the structure, and now it can form retinol or retinal, which can also be transformed into other nutrients. So, basic line here, know that precursors are inactive forms of vitamins, and they're also known sometimes as provitamins. All right, now if you look at this feature and you've been following along with some of my slides, this may be a very familiar graphic here. And I would say that it's not going to be as involved as our previous lectures or chapters because vitamins are not digested. They're already in a simple, unique structure. So we don't have to have well, itself, we don't have to have bile, but remember that vitamins are in foods with particular nutrients. So if we need to separate the vitamin from, let's say, a protein, we're going to need some things like either acid, hydrochloric acid, pepsin in order to free the vitamin. But the vitamin structure itself, which is what I was trying to say, is not going to be changed. It's already ready to go in its simplest form. The only difference is that if it is a fat soluble vitamin, it's going to require fat itself within the diet. And that's because we're going to form very exactly the same as we saw within the lipid chapter. It's going to form a micelle with the fatty foods in there, like triglycerides, and it's going to follow the same pathway and enter into the lymphatic vessel through the lymphatic system, and eventually it's going to hit the hepatic portal vein and be stored in the liver. Our water soluble vitamins, they are going to be enter into the circulatory system. Some of them are going to require facilitated diffusion. Some of them are going to require active diffusion. I'm not going to ask you for this course to know which ones require simple diffusion or active or facilitated in order to get into what this is. This is an enterocyte. So what you need to know, I'd read through this. Hey, in the mouth, we're going to chew it. We're going to break apart maybe fibers that's holding on to that particular vitamin. And then it's going to enter into the stomach. If we have protein, we got to separate the protein from that vitamin. It's going to enter into this small intestine here. Within the small intestine, it's going to be absorbed here. We might still need some more breaking away from macros to get it freed. But once we do, we're going to have mostly vitamin B's, the B vitamins, and vitamin C entering into the circulatory system, into the blood vessels. They are going to go directly into the hepatic portal vein. Our lymphatic system is going to have to go into a little bit longer route itself, and eventually, though, it is going to meet up with the hepatic portal vein and enter into the liver. As I was mentioning on the previous slide, our vitamins are sometimes attached to food substances. For instance, on this very first bullet point here, it says they're attached to proteins in our foods, and yes, some of them are. And so, because of that, we have to have the enzyme pepsin and hydrochloric acid in order to take off that protein and allow that free passage of the vitamin itself. So, we need those two in order to release them from their food components. If it is a fat soluble vitamin, A, D, E, or K, ADDIC, then we're going to require fat in order to digest it. Here's fat soluble vitamins. They're going to be packaged in chylomicrons. That's the same thing that you learned, or hopefully learned within our lipid chapter. Same passageway there. If you do not have fat in your diet, let's say you go on an extreme low fat diet, then you will have problems with fatty acid deficiency and fat soluble vitamin deficiency. Good example of this is with what's known as TPN, or total parenteral nutrition, in a hospital. If you are especially maybe you have a loved one who goes on a feeding tube in the hospital, then sometimes it's put into the vein. And what we do is we start out with carbs and protein first, and later on, once the patient is stabilized real good, we'll add in lipids. And those lipids, if let's just say they get missed, and sometimes it happens because it's a separate order, then if it's prolonged, they'll start to have different signs and symptoms of deficiencies related to either some certain specific fatty acids or A, D, E, or K. So these are very, very important things in nutrients in order to have. It just takes a lot longer in order to have those deficiencies show up. Okay, water soluble vitamins directly absorbed into the bloodstream. Looking at this, I think this is a good thing to point out. My cells are required. Remember, I'm going to draw a. I'm sorry, I'm not artistic, but let's say that this is our small intestine, and we have, remember, the brush border that's lining the small intestine, and within the brush border we have cells. Okay, and I'm going to draw a bigger cell here. All right, within the cell, once it gets into the brush border, we have the formation of what is known as a chylomicron. I'm going to just use C since I have a stylus and it's not very specific. That is what gets it into the lymphatic system. I need you to connect the fat soluble vitamins once they're in the small intestine. They get in to the brush border with by forming a micelle, and that micelle looks very similar to a chylomicron. It has fats within it. It has emulsifiers or phospholipids surrounding it. But the point is to get that fat close enough to the brush border to get into the cell. Chylomicrons leave the cell and go into the lymphatic system. So two different components there, and I think it's a good thing to note within this chapter. Now, when we get food from the marketplace, or even if you are a farmer and you actually grow your own vegetables, we can change how much of that vitamin is in that food or the bioavailability of it from the time that you get it until it enters our own body. And that really it depends on how you store that, how early on you prep the food, and then what degree you change either the heat or the acidity in that cooking environment. So note these different factors. This is a very good list to understand. Know that oxygen or exposure to it. Let's say I have an apple and I cut it, open it up, oxygen is now exposed to it and it begins to destroy it. Mm, Depending on how long it's exposed to oxygen, maybe you just now cut it and you're going to serve it, not a big deal. You say you cut it and you leave it in the refrigerator because you're meal prepping. Well, by the time, let's say a couple days later, that you are actually consuming that apple, you're not going to necessarily get as much. Still you can get some, so I don't want to deter you from meal prepping. It's still going to provide you great nutrients, but it'll be less of it. Exposure to ultraviolet light, water. There are water soluble nutrients, so B vitamins and vitamin C. If they are soaked in water, those vitamins can leach out of that particular food and get into the water. Changes in pH. An example of this is noted here. Something that we do in culinary is that if we want to make the food more aesthetic, pleasing to the eye, we want to brighten the color of green beans, we can change its pH by adding either a base to it, um, and or giving an example is cream of tartar, and it will brighten the color of the vegetables. Otherwise, if you cook the heck out of green beans, you're going to be served with something that looks like this. Of course, if we are catering a big event, we don't want that to happen, and we can change it. But unfortunately, when we do, then we destroy the nutrients in it. Also, heat. If we have a very long cooking period of time or a high cooking period of time, it can also destroy those nutrients. Not, I don't want to, again, alarm cooking methods or meal prepping. It just depends on how variable your diet is. If you only ate the same thing and you cooked only the same way, then yes, it would be an issue. But understand that these are some major factors that can impact nutrients or nutrient bioavailability. Good chart to read through here. How can we maintain the highest amount of nutrients within our foods? Cook vegetables within the smallest amount of water, knowing that if it's water soluble vitamins in that particular food, that it's going to end up in the water by the time you get through. They will say that you can use that leftover water in order to make a soup or a gravy or a base, but I have not seen too many people who actually do that, but it's great if you do. Don't rinse your rice before cooking it. So if you're a big rice eater, this is something that's a major staple to you. If you rinse off the rice, it is going to pull the B vitamins that are very valuable within the rice. If you microwave or stir fry your vegetables instead of boiling them, then you're going to preserve it because it's not as long of a cooking temperature and not as high of a heat. If you store your produce in the refrigerator, uh, immediately and seal it up. I would say keeping it not exposed to oxygen. Don't leave it out too long on the counter. Then go ahead and eat it. That's why a lot of people will visit those markets on a regular couple of days throughout the week. You have that fresh produce. You're going to get the most nutrients for your buck. And then cut vegetables and fruits in larger pieces. When you have, let's say, a tomato and you cut it in fourths, you're not going to have as much surface area for oxygen to affect the nutrients in order to destroy them. So cutting them into larger pieces instead of dicing them, if you're meal prepping, will also help to preserve the nutrients in them. Something I would just like to mention here and emphasize is that fresh is not always the best. Surprisingly, when we look at plain Jane, let's say frozen green beans, you go to Walmart, get it out of the shelf, you think, well, that's not as good as me going and getting it out of the produce section. Well, that's not true, because in the farm, when they harvest them, they are taken immediately to the facility where they're going to be processed very, very quickly. They're going to be rinsed real quickly, and they're going to be preserved in an airtight package. And so they're going to have a lot of nutrients that are not being leached out. If you have, let's say, a farmer who picks his produce, and then it's got to be traveled to the grocery store, and it's going to lay out in the shelves, exposed again to oxygen. And then you yourself coming eventually and getting that particular type of fruit or vegetable, it's been exposed to the elements a lot longer. And so it's not necessarily always better to have fresh. Not to say I don't want you to eat fresh fruits and vegetables. I definitely do want you to do so, but understand that frozen is a great source of nutrients as well. All right, another term that is important to understand is fortification, and that is means the addition. I'm just going to fortify or add to the food that I have. And this is different from what you have already learned, which is enrichment. Enrichment is a type of fortification, but it is different in being that enriched nutrients were already there in that food. And what we're doing is we're taking the nutrients that were lost in cooking or processing and we're putting them back. Fortification means that, hey, I'm adding in, it could be some amount of nutrients that were originally there. It could be things that were never in that product. A good example is calcium in orange juice. That is fortified. It's not a naturally high nutrient in orange juice, so it's fortified in there. Enriched bread, let's say white bread, when that original wheat grain was stripped and processed, the B vitamins were lost, many of them at least, in processing. And so what they do is after that bread is made is they enrich it back through putting those vitamins back into that food. Those are the two different things. It is a good idea to understand these are the mandatory enriched nutrients. So anytime you have white rice or white bread, processed, let's say pasta, these nutrients, thiamine, niacin, riboflavin, folate, and iron, all B vitamins except for one mineral here, these have to be added back to them because we have very big problems around the world with deficiencies and diseases related to this. Now, if you see something extra onto it, it's probably a fortified one. So fortification was first mandated by the government in order to help to alleviate some of the diseases that were widespread, like rickets, uh, and then also birth defects. And we'll see a few others later on. But now it's more popular. It's the marketers that are working for big companies that want to be able to sell their products. So they fortify these with nutrients and know that, hey, if I feel like I'm getting more nutrients with this orange juice compared to this orange juice, it's probably going to be chosen over the other one. Unfortunately, now we might start to have issues with toxicity because of it, because so many different foods are being enriched and fortified.